Hello everyone, and welcome. This is the second video in our tutorial series on using the query tool in the QSAR Toolbox. If you haven't watched already, check out Tutorial Query Tool, a acute aquatic toxicity example for an introduction to the query tool and its core features. In this video, we'll walk you through how to search for lipophilic chemicals with low bioaccumulation potential associated with a specific test organism and duration range. To begin, go to the Data module and first unselect all for the sections Databases, Metabolite Databases, and Inventories. After that, go to the Databases section and select the checkbox for Environmental Fate and Transport. This ensures that the search is focused on experimental data related to bioaccumulation. Next, return to the Input module and click the Query button. Click Yes on the message that appears. If you have already used the query tool in the current working session of the QSAR Toolbox, another message will display suggesting that you restore the previously selected database. Answer No to this message. Now we see the main interface for the query tool, and we need to clear the tree logic panel. Select any of the objects here to enable the Clear button, and then clear the space. Our task is to find lipophilic substances that are not bioaccumulative. So, at first, we define the lipophilic criteria, which is based on octanol water partition coefficient. To define the rule, we need to go to the Parameters tab, expand 2D calculators, or use the filter and find log cal from the list, select it. In the expression field, set the value to be greater than 4.5. This is the reach threshold for potentially bioaccumulative compounds. Click Add to include this condition in the query tree logic panel. The lipophilic criteria is set. Now, let's define the second part of the query, the bioaccumulation data rule. For this purpose, go to the Data tab and expand the levels Environmental Fate and Transport, Bioaccumulation, Aquatic Sediment. Choose BCF Bioconcentration Factor under Bioaccumulation Aquatic Sediment. After that, we need to go down to the Metadata section. Here we are going to define the test organism. So, open the drop-down list and select Test Organism Species, and do not forget to click the Add button next to it. A new field appears down, and now we are going to select a specific fish. Open the drop-down list under Test Organism Species, and by using the filter, find Saprinus carpio. Then click the Add button next to it. The test organism is set. Now, let's move to the next section, Descriptors Numerical Metadata, where we are going to define duration range between 42 and 56 days. First, select duration in the drop-down menu or use the filter to find it, and after that, click the Add button. Here, we are working with a mean value, so set the mean value to range from the drop-down list, and after that, put 42 and 56 in the appeared to fields. We need to set the unit as well. Select time from the drop-down list, and after that, select letter D from the drop-down list, which corresponds to days. The duration is set. Now, let's go to the Data section, where we are going to define the BCF criteria. For this purpose, we are using the mean value, and from the drop-down list, select the less than sign, and after that, put 2000 in the field. Here the unit is specific volume, so we need to find and select it from the list, and then we need to find and select liter per kilogram in the next field. The data criteria is set. Once all criteria are set, click the Add button at the bottom, and the query appears in the Query Tree panel. To combine the two queries, we need to right-click each of them to highlight them in orange. Then, click the End button at the top to connect them. Now, click Execute at the bottom to run the search. It starts working, and in seconds will come up with results. Click OK in the message with results. The chemicals with their experimental BCF data are collected on the data matrix. Expand the endpoint tree to the last level, and here we see the specific test organism. We selected a Saprinus carpio. Also, the data are collected for the specific duration range we defined between 42 and 56 days. And all the data here on the data matrix are less than 2000 liter per kilogram, currently represented in their log units. To see them as liter per kilogram, we need to change the setting. So, go to the settings, expand the first level general, and then expand the sublevel data matrix. Select Preferred Units level. Now we see a table summarizing the families of units in QSAR Toolbox. Here, we need to find the row-specific volume and open it with the arrow. Select the row with the same name, specific volume, and now we see the units related to this family. Keep the preferred unit as it is defined liter per kilogram and change the expression which is shown down in the list to be as it is. Then click the button Set as default followed by the OK button. Finally, click Yes in the message that appears. The BCF units are changed to liter per kilogram. To view the calculated log cow values, go to the endpoint tree level parameters and expand 2D level. Locate log cow and right-click on the row of log cow from the menu that appears. Select Calculate/Extract log cow for all chemicals. Now let's order the results in ascending order. To do this, once again right-click on the row of log cow, select Sort from the menu, and after that ascending order. Now the results are ordered ascendingly. In case of mixtures, there are more calculated results for each of the mixture's constituent, and at least one of them matches the criteria to be higher than 4.5. To export the results to Excel, refer to Tutorial 12 on ECHA's YouTube channel. Congratulations! You've now learned how to use the Query tool to search for lipophilic, non-bioaccumulative chemicals. More tutorials are on the way. Stay tuned. Contact QSAR Help Desk for technical questions. If your question concerns policy or regulatory acceptance of Toolbox results within EU regulations of ECHA's competence, please refer to the ECHA website directly.